Welcome, Algebra 1. We are going to start today by talking about simplifying radicals. This is going to be just like kind of a small section before we prep for actually like our last section of the year. This is just going to be kind of like a hodgepodge of things put together to prep you for a few things that you're going to see in the next unit and what like a huge part of geometry. So it's a small section, but it's super, super important. So this is actually part of chapter 10. It's 10.2, simplifying radicals. So we're going to start first with just parts of a radical. So the nth root of a number, a, can be written as the radical expression, the nth root of a. And so we say that first as the nth root of a. So let's actually write that down of how we would say that. So that would be nth root of a is how that would be like read. Okay, so there are three different parts that are important here. So the first part is this letter N. And so what N is called the index number. So that N here is called my index number. Index number. So what the index number basically says is like, it's basically telling me, like basically like with a square, we're looking for two of the same numbers that are being multiplied together. If it was a cube root, we'd be looking for three of the same numbers that are being multiplied together. So we're looking, that's like the amount of group or the size of the group that we're looking for. And then we have, let's see, this. And you guys know what this is called. That's called a radical. So that is the radical portion. And then what some of you guys might not know what it's called is the A. So the number or the variable, whatever is within the radical, that's called the radicand. So radicand, that's always like the number or the variable that's within the square root or the cube root or whatever root. So radicand. So oftentimes though, you're not going to see an index number. If you look at like 1 through 6, there's not an index number on the outside of the square root. If there is no index number, it's assumed that n is equal to 2. And all that's saying is it's just a square root. So when there is no like index number, we always assume it's a square root. Okay, so what I want you guys to do is I want you guys to think about our perfect squares. So our perfect squares are the number that basically we can take a square root of. So a perfect square, my first perfect square would be 1. 1 times 1 is 1. And then 2 times 2 is 4. 3 times 3 is 9. And I want you guys to actually complete that on your own. So do all the way up to 15 times 15 and get those perfect squares, because obviously this plays a huge part in simplifying radicals. So pause me here, get those on your own, and then come back, make sure you guys have the same thing. Okay, so you should have, going after 9, you should have 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and if only this was just a tad bigger, 225. So those are your perfect squares, and those really are going to help us when we're simplifying a little bit more challenging square roots and cube roots. So those are always really helpful to kind of keep in mind when you guys are going through this process. So sometimes I'll even have those written out on a piece of paper while I'm going through this entire section. So if you guys want to have that out and have your perfect square roots, and then we're going to get to cubes in a second, that's great. That will totally be helpful. Okay, so let's look at number 1. What's the square root of 64? So again, the square root, or the index number, what I was saying here, we know 64 is 8 times 8. And so we know that there is a group of 2 here of the same number, a group of 8s. And so what happens is the square root of 64, since I have 2 of the same number, it comes out to be 8. Now, what I want you guys to do, pause me here, take the square root of 121 on your own. Hopefully you can use the above numbers to help you, and then come back and check your work. Okay, so the square root of 121, we know, okay, what times itself is 121? Well, that's 11. So notice there are 2 of the same numbers again. And so when we have that, 2 of the same numbers inside the square root, one of them comes out. And so the square root of 121 is 11. Okay, so with 14 rad 9. So there are 2 parts of this. I want you guys to first ignore the 14, and I just want you to look at the square root of 9. And I also, so let's just focus on that. So the square root of 9, we know, okay, think about what's the square root of 9. We know the square root of 9 is 3. And so what's happening, what operation is happening between 14 and the rad 9? Well, they're right next to each other. So remember, when 2 numbers are right next to each other, that means that they're multiplying together. So these 2 numbers are multiplying. So when we simplify the rad 9, we're going to multiply it by what it simplified, which it's simplified to be 3. And then we're just going to do that. If you need to use your calculator, use your calculator. 14 times 3 gets me 42. Okay, so I want you guys to just pause me here. Try number 4 on your own. Same thing as 3, and then come back, check your work to see how you guys did on that one. Okay, so for number 4, we're looking at -3 times rad 36, or often I just say -3 rad 36. So again, they're multiplying in between here. And so we can simplify this rad 36. We know what the square root of 36 is. We know that's 6. And then I can multiply my numbers together. -3 times 6 is -18. And that's it. Okay, so we're going to move on to 5 and 6. So 5 and 6 are both fractions. And they're both, the fraction is the entire thing is within the square root. And so sometimes what I'll do, and how I think it's easier to think about, so instead of thinking about what's the square root of rad 25 over 64, I like to actually think about it instead as what's the square root of 25 divided by the square root of 64. I know some of you guys are like, that's the same thing. And some of you guys are like, oh, great, that's the same thing. Because what we can do now is look at it just part by part. What's the square root of the top? Well, the square root of 25 is 5. And then what's the square root of the bottom? Well, the square root of 64 is 8. So I can just simplify that to be 5 over 8. And I double check, is there anything that I can simplify further? 5 over 8, is that like fraction? Can I reduce that? And I can't. So that is my final answer. Okay, so I want you guys to pause me here, try number 6 on your own, and see if you can do that one, and then come back and check your work. Okay, so again, you guys can rewrite this one as the square root of 9 over the square root of 100. And we know, okay, what is the square root of 9? Well, the square root of 9 is 3. And what's the square root of 100? Well, the square root of 100 is 10. So we get 3 over 10. I double check, is that something that I can reduce? And it's not, so then I'm going to box it. And so those are just some examples of perfect squares. Now we're going to look at our perfect cubes. So perfect cubes are numbers being multiplied by itself 3 times. So, okay, 1 times 1 times 1 is still just 1. 2 times 2 times 2, if you guys need to do those in a calculator, 2 times 2 times 2, and that gets you 8. You guys can always use your calculator. 3 times 3 times 3. That gets me 27. And so what I want you guys to do is keep going with those just like we did up above. So try to finish those just up until 10 times 10 times 10. So get those on your own and then come back and make sure you multiplied correctly. Okay, so 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1000. Okay, so we're just going to go through here and simplify. We can start by taking, okay, well, what's the cube root of 27? So now my index number is 3. Just like up above how my index number was 2 and I was looking for 2 of the same numbers. When you're looking for a cube root, you're looking for 3 of the same numbers. 27 is 3 times 3 times 3. And so there's a group of 3 threes. It's a lot of 3s in there. And so the cube root of 27 would be 3. So I want you guys to think, what is the cube root of 125? Use the perfect cubes up above and simplify that. Okay, so you should have thought about that. What times itself 3 times is 125? And if you thought 5, you are correct. So the cube root of 125 is 5. Okay, so typically you wouldn't be able to take the square root of an even or of a negative number. Now, that is true. So if for any even index number, you can't take the root of a negative number. But if it's odd, like this one is, the index number is 3, the index number is 3, you can take the cube root of a negative number. So if we take the cube root of negative 64, well, let's ignore the negative for right now and just think, what's the cube root of 64? What times itself 3 times gets me 64? So I'm going to ignore here and I'm just going to think, okay, that's 4 times 4 times 4. Okay, now how do we make that? We know 4 times 4 times 4 is a positive 64, but what if to make a negative 64, I make this negative, negative, negative? So negative 4 times negative 4 times negative 4, and negative times itself 3 times gets me still a negative number. And so the cube root of negative 64 is negative 4. So anytime you have a cube root of a negative number, you can always take a negative out. So you can always, you should always be taking a negative number out. Okay, so for 10, I want you guys to pause me here, try 10 on your own, and then come back and make sure you did that correctly. Okay, so we're thinking what times itself 3 times gets me negative 8, and that's negative 2 times negative 2 times negative 2. So the cube root of negative 8 is negative 2. Okay, so what we've been dealing with on this sheet is all perfect square roots or cube roots. So basically they all can be we can all get a whole number every single time. Now what we're going to talk about on the next side is simplifying non-perfect roots. So what that means, if the radical is not a perfect square, so if it's not one of those, 15 numbers that we had for the squares or the cubes or whatever, what we're going to do is we are going to follow these 3 steps here. So our first step is going to be to find the largest perfect root that the radicand is divisible by. And then from there, we'll break the radical down using the largest perfect root. So whatever that perfect root is that it's divisible by, we're going to divide it by that. Okay, then we are going to take the root of the perfect square, cube, etc., whatever it is that the index number is, and we're going to take it out of the radicand. So I'm going to add that. So this comes out of the radical. And then whatever is left, we leave the leftover under the radical symbol. So if there is a coefficient outside the radical, just like there was in those examples on the other side, so like on 3 and 4, if there's a number in front of the radical, multiply this with any number you take out of the radical symbol. Okay, so that sounds kind of weird, but let's break it down when we're doing our examples. Okay, so the square root of 12. Now I'm going to show you 2 ways that I process this. But the first I'm going to show you is using these steps. Okay, so I think first, what is one of my perfect square roots that are divisible by, or 12 is divisible by? So my perfect square roots, or my perfect squares, are the ones that we listed on the prior page. So that 1, 4, 9, 16, 25, etc., etc. So if you want to list those on the side here, that might be helpful. If you just have that out, it's super helpful. So I think, okay, so what number goes evenly into 12? Now, I know most of you guys are thinking it in your head, but I'm just going to kind of go through the process of how I would do it with any number, something that I don't know off the top of my head. So I think, okay, what's the smallest, what's the square root that's smaller than 12? And the first one would be 9. And I think, does 9 go evenly into 12? And it doesn't, so I'd go smaller. And I think, okay, what about 4? Does 4 go evenly into 12? And it does. So that's what it's saying. First, find the largest perfect root that the radicand is divisible by and break the radical down using the largest perfect root. And so we're going to break it down. We know, okay, 4 goes evenly into 12 3 times. Okay, so from there, that was my first step. So then I'm going to take the root of the perfect square or cube or whatever. In this case, it's a perfect square. And think, okay, what is the square root of 4? Well, the square root of 4 is 2. So that number is going to come out of the radical. And then this third step, it says leave the leftover under the radical symbol. So my leftover is the 3. We don't know what the square root of 3 is, so we're just going to leave it inside the radical. And so the square root of 12, and that's a terrible 3, so I'm going to just white it out and rewrite it, sorry. So the square root of 12 can be simplified to be 2 rad 3. And we use this a ton. This is something that we're going to, like I said, use in the next unit. I use this in Honors Algebra 2 all the time. You use this in geometry. It's something that is going to kind of follow you through for your next couple of years in math. So it's super important that, you kind of start to see it. You'll, learn more about it next year and kind of further it and further it. Okay, so if you're feeling really good and you want to keep going and you want to try 2 on your own, great. If you, aren't ready to do 1 on your own, that's fine too. We can do this one together. Okay, so the square root of 24. I think what number is divisible by 24? That's a perfect square root. So I always think about basically a number that's like a perfect square that's less than 24. And so the first one would be 16. So does 16 go evenly into 24? And it doesn't. Okay, so then I keep going and I think about 9. Does 9 go evenly into 24? And it doesn't. So then I go to 4. Does 4 go evenly into 24? And it sure does. So we're going to break that down using 4. 4 goes into 24 6 times. And so I can now simplify that way. So I know what the square root of 4 is. The square root of 4 is 2, so 2 is going to come out. And then my leftover, which is 6, is going to stay inside the square root. And that's my final answer. Now, I told you guys I would show you 2 ways of doing this, and I'll show you guys both, like how I would do this on both 1 and 2, but then for 3 and 4, I'm just going to stick to this method. So whatever makes sense to you guys, please use that method. It's totally up to you. I think both are valid, and I use actually both depending on what type of problem it is. Okay, so if I'm looking at the square root of 12, so here is my other method of solving this. I break it down. I don't know if you guys want to throw it back to, elementary school, but I break it down into a factor tree. And so I'm thinking of the numbers that make up 12. And so we know, okay, 12 is 2 times 6. And then I think, okay, can I break up 2 further? And I can't. Can I break up 6 further? And I can. So I'm going to cross out 6 because we're going to break that up to be 2 and 3. And so now I know I'm taking the square root. And so square root means I'm looking for a group of 2 of the same numbers. And I have 2 of the same numbers. I have 2 2s. So when I have a group of 2 of the same numbers, that number can come out of the square root. The 2 comes out. And then what's left that's not circled, that doesn't have a pair, stays inside the square root. So that would be my final answer. The 2 comes out, the 3 stays in, so it's 2 rad 3. Okay, so if we were to do that again, showing that different method with the square root of 24, Okay, I know 24, let's say, is going to be 8 times 3. Can I break up 8 further? And I can. So 8, I know, okay, I can cross that out. And that's 2 times 4. And then I can't break up 2 any further, but I can break up 4 further to be 2 and 2. So again, I'm looking for what are my perfect, what are my groups of 2 of the same numbers? Well, I have a group of 2 2s. So the 2 can come out of the radical, and then 2 doesn't have like a partner. 3 doesn't have a partner. And so 2 and 3 stay inside the radical, and 2 times 3 is 6. So both methods work. They're always going to get you the same answer. It's just a matter of which one makes more sense to you. So, like I said, on 3 and 4, I'm going to use the first method that we talked about. But if you feel more comfortable doing it this way, that's totally fine too. Sometimes it's just like a bigger number, and so it's kind of a pain. But it depends, I don't care how you guys think about it. Both, like I said, are going to get you to the same answer. Okay, so for number 3, we have the square root of 48. So the square root of 48, I think, what's my perfect square that goes evenly into 48? So I first would think 36. Does 36 go evenly into 48? And it doesn't. Then I think, okay, 25. Does 25 go evenly into 48? And it doesn't. And then I think, well, what about 16? And honestly, what if I wasn't sure? Well, that's why we have a calculator. So I can go, does 16 go into 48? And it does. 16 times 3 gets me 48, so I can break it up that way. And so we know what the square root of 16 is. The square root of 16 is 4, so 4 can come out of the square root. And then what's left, my leftover, is 3. So my answer here is 4 rad 3. So the leftover always stays inside the radical. The perfect square always comes out of the radical. Okay, so pause me here. I want you guys to try 4 on your own, see if you guys can do it, and then come back and check your work. Okay, so let's look at 4 and make sure you guys did that correctly. So let's say you didn't know. You were unsure what divided evenly into 63. And so what you could do, and sometimes what I'll do if the number is bigger and I don't know it off the top of my head, I'll just start dividing. Does 49 go into 63? Because that's the biggest number that's smaller than 63. And it doesn't, so I'd go down. Okay, what about 36? Not even. 63, what about 25? It doesn't. Okay, what about 16? Still not there. Okay, hopefully 9 does, which we know it does. And so that's another way that you guys can just do it in your calculator. It's like a guess and check type of thing there. Okay, so we know 63 breaks up into be 9 and 7. And then we know, okay, well, what's the square root of 9? The square root of 9 is 3. And then we can't take the square root of 7. So that's my leftover. And that's what stays inside the radical. And that's my final answer. Okay, so those were all 1, 2, 3, and 4 were all square roots, right? There was no number on the outside, so those were all square roots. Now 5 and 6 are cube roots, so we have to think of our perfect cubes. And again, I'm going to show you both methods, just like I did on 1 and 2, but I'll first show you using the perfect cube. So 1, 8, 27, 64. So again, if you want to write those on the side, if you just want to have your sheet out, whatever you want to do. Okay, so with 40, I'm thinking, what's this largest perfect cube that divides evenly into 40? So again, you can do like a guess and check here if you don't know. Well, does 27 go into 40? Because I can't do 64. 64 is bigger than 40. And it doesn't. So, well, what about 8? Which we know it does. 8 times 5 gets me 40. So I can break up 40 to be 8 and 5. And so now we know, okay, the cube root of 8 is 2. So 2 can come out. And then what's left is the 5. Now what's really important here is we're taking the cube root. So when you write the leftover, you're writing it as the cube root of 5. You can't just write it as the square root. That wouldn't make sense. So whatever the index number is, the index number, like you still need to use that in the leftover. So that would be my final answer. Now, if you wanted to see how I did it, like how I would do it like I did up here in this different method. So the cube root of 40, I'd start the same way. I'd start by breaking it up into its factor tree. So I know, okay, 40 is 4 times 10. Okay, can I break up 4? Yep, I can. It's 2 and 2. Can I break up 10? Yep, 2 and 5. So now because of the cube root, instead of looking for groups of 2 of the same number, I'm now looking for groups of 3 of the same number. So I have a 2, 2, and a 2. I have 3 2s. And so that 2 can come out. And then what's left, the leftover 5, stays inside the radical. So you get the same answer, 2 and the cube root of 5, no matter which way you do it, which method you use. Okay, so I want you guys to pause me here. I want you guys to try 6 on your own and then come back and make sure that you guys got the right answer. Okay, so whatever method you guys chose to use, whether it be, breaking it up using the perfect cubes or breaking it up using the factor tree, hopefully you still get to the same point. So what I would do is I would think, okay, so 192, I think, does it go evenly? Does 125 go evenly into it? Which it doesn't. Well, what about 64? Oh, and it does. So I'm going to break up 192 into 64 and 3. So I know the cube root of 64. The cube root of 64 is 4. 4 times 4 times 4 gets me 64. And then what's left is the 3, and so it's going to be the cube root of 3. And that is my final answer. And that's it for the notes for today. So if you guys have any questions on any of these, please feel free to come to the office hours. Remember, office hours are Tuesday and Thursday from 2 to 2:45. So come by, get help, ask your questions, email me, whatever you guys need. I'm always happy to help you guys. So I hope you guys have a good rest of your day, and I will talk to you soon.